Yes. Sure, I can. Okay, and the chat box is open, so if you don't want to say anything, you can just nod in the chat box so you can see my screen. If you can't at any time, just be sure you let me know, okay? So this is the normal distribution. So we have, if you've had me before, or if you remember from anywhere of your back in the day when you learned the 68, 95, 99 rule. Okay, math does not change. I said that earlier. It does not change at all. Okay, so what we know is if there's 100 people in the world, if there are 100 people in the world, it'll always be the same. The assumption is that most of the people will be toward the middle. So my 68th percentile, which is my first standard deviation, is always going to be the same. Okay, so if the mean, median, and mode line up, then I have a normal distribution. My mean is the average, right? Add the numbers together, divide by however many numbers there are. The median, I always remember, it's the green part in the highway, you know, so if I cross the median, I could kill myself. And then the mode is the number that is repeated the most often. Okay, so 68, 95, it's 95 and change. So in some tests, you might see 96. 68, 95, 99 rule. The biggest one is the pink. That is the regression. People, things tend to regress toward the middle. We tend to be like everybody else. We want to go toward the middle. That U sign is right there with the curvy kind of O. That's standard deviation. So then my mean, median, and mode, which are also called the central tendency, all line up in the middle. My first standard deviation is 68%. My second one, I'm going to add the pink to the purple, and that's going to give me my 95 or 96%. And then my green added to that takes me to the 99th percent, 99%. That is my third standard deviation. So those will never, ever change. First, second, and third. So if the question is, little Johnny scored 78%, what standard deviation did he score in is going to be the second, because it has to be less than 68 to be the first. And then it's between 68 and 95 is going to be my second standard deviation. Okay. So that's all that means. And again, there are going to be some things as we go over that, you don't need to know why. Not for the test. If you want to know why in the real world, schedule a session with me and I'll explain it to you. But for the test, we're just going to go over kind of what you need to know. And these are things that you need to know. The mean, median, and mode will line up. Okay, so I give you that to say we're going to go back to then what it looks like. So what I suggest to some people, or just to all the people, either memorize this or write it down. It is going to save you some headache when it comes to the test. And what I get is, do I have to write it all down? I suggest that you learn a good chunk of it. If you look at Rosenthal's book, if you look in Helwig's book, there is some version of this. Okay, the goal is you have to line them up because they're going to ask you to compare things. So when I'm asking you to compare, it's always going to be based on the normal bell curve. Okay, so you see at the normal bell curve, my mean, median, and mode, again, that is my central tendency. That is the exact middle, is the highest point. Mean, median, mode, all lined up, highest point. I get my 68% by adding 34 and 34. See between the -1 and the +1? Again, that's the largest area, and that's going to be my first standard deviation between the -1 and the +1. If I add 13, 34, 13, and 34, if I add the first four together, that's where I get my 95th percentile. Okay, and then I'm going to add the 2.14 again all the way up. That's where I get my 99 and change for 99.75. My 0.13% on both sides, those are considered my outliers. Those are people who just can't follow the rules. Okay? If you know me, I'm probably one of the outliers. Just I have difficulty sticking with the rules. So that's my normal bell curve. So what I do know is I'm going to always be comparing those to my Z and my T-scores. Z and T-scores are transformed or standardized scores. Okay, so if I take a test with 20 questions and you take a test with 15 questions, we can't compare those. Because, you know, if I say I got 10 right and you got 10 right, it's not the same. So they've been transformed, so they become standardized scores. So Z scores and T scores are standardized. If you will notice, my Z score is going to line up the same with my standard deviations. Okay, so I'm going to have a Z score of 0 will be the same as my mean, median, mode, my central tendency. -2, -3, -4, and it goes up the same way. Okay, my T scores go up and down by 10. And please don't think a T score is the same as a T test. Okay, so a T test has to do with testing. It has more to do with my assessment piece. T scores have to do with my bell curve. Okay, and again, they have been transformed, standardized to be able to compare to each other. Then my stanines, the stanines, and if you ever you have a kid, you're a counselor, your kid, when you get a thing, he came home and he said, "Mom, I'm in the 99th percentile." Like, what does that mean? So if you see the percentiles, that's what that means. That there were, 98% of he was ahead of 98% of the children in the same grade that took the same test. Okay. And then again, so the percentiles at the bottom, there are 9 percentiles. And what I do know, the easiest way to remember is the 2nd through the 8th percentile, 2, 3, 4, 5, 6, 7, 8. My 5, see, lines up with my mean, the middle one. And my 2 through 8 are going to be within the 2nd standard deviation. So what you will get, and the reason it's important to know these, is you'll get a question comparing these. They'll ask you, so according to a T-score, Bobby scored a 40 on his T-score. His friend scored, his friend was in the 1st standard deviation on his Z-score. Who scored the highest? So all they're asking you to do is line them up and then figure out like who is the highest. This is a number line. The numbers go up. Okay. So remember, the middle is 0. As I go to the left, it's going to be negative. As I go to the right, it's positive. So I do know that my positive score, of course, is going to be on the right. Okay. That's the best of all worlds when everything is lined up. What happens when they don't line up? Exactly. So when they don't line up, I'm going to have then a skew, right? So my skew is when those things do not line up. Sorry, I'm looking for my book I want to use. There we go. That one. Okay. So in general, a skew is either positive or negative. So what I do know is of my 3 numbers, mode, median, and median, I said to you earlier, the mode is the number that appears the most often. So if the mode appears the most often, that is going to be the number that is on the top of my skew. Okay, since they don't line up, right? Because if they lined up, then I'd be looking at a normal bell curve. But on a skew, the numbers don't line up. So my mode is always going to be the highest point because I have more than one number. That's the mode. Okay, so my mode will be the highest point. So the question will ask me, where is my mean or median in relationship to my mode? Ice cream a la mode. The mode is always the highest point. So then as I look back, if my mean is lower than my mode, it's going to be a negative skew, a negative tail. Remember, this is the number line. So 0, 1, 2, 3, 4 is positive. Negative 1, 2, 3, 4, 5, 6, that's my negative. So the question will ask me, Bobby had a mode of 65, but his mean score was 35. Was that a negative or a positive skew? It's a negative skew because his mean score is lower than the mode. Okay, other way. So then again, my right skew, that's my positive. Number line, they're going up. So my mode is the highest again. So if Barbara has a mean score of 60 and her mode score was 85, I'm sorry, no. So her mode score would be 55 and her mean score would be 65. I know it's a right skew going up. Okay, so my mode, anything below going down is going to be a left skew or a negative, and then if it's higher than the mode, it's going to be right. So remember, mode is ice cream a la mode. It will always be on top if the median, mean, and mode don't line up. Okay, questions? I haven't bit anyone in a long time, I promise. Okay. It doesn't matter what source you use. The information will never change. Facts are facts are facts, and those will never change, especially when it comes to our research and our assessment. Okay, that's what I just went over a minute ago. My measures of central tendency. I reminded you that the mean, and you might recognize that score, that symbol. Mean is the average. Median is the exact middle. That's the green part. And my mode is the number that appears the most often. You can have a bimodal set of numbers. So that would mean if you have a distribution, those are my numbers, and I have 2 5s and 2 6s, that's bimodal because I have two sets of numbers that still have repeated the number twice. That's bimodal. Okay. I talked about your skew. So a positive skew, again, I'm always going to know that my mode is the highest point. I'm going to go to the right. Okay. If it's a negative skew, I'm going to the left because, again, the mode is always the highest point. It matters where the mean is in relationship to the mode. Okay. What's my range? Anybody know?
Highest
range. Thank you. Go ahead.
Number.
Say again, babe.
The highest number minus the lowest number.
Exactly. Okay. So I'm going to see. Good. Very good. So I'll use the range when there's a small distribution. A teacher has 9 students. Okay, and she wants to know, what the average was or how she did with those 9 students. So they will give you like 5 or 6, 7 numbers. You will subtract the lowest number from the highest number. So if the highest score was 100 and the lowest score was a 75, then my range is 25. Okay, my inclusive range, how do I get that?
You add 1.
I do. That means everybody in the party, everybody in is inclusive. My inclusive range is I add 1 to it. Okay, so make sure when you're reading those questions and the answers lie in the questions, go back to the question and make sure that you know what they're asking you. So then if it says I'm looking for the inclusive range, I'm going to subtract the lowest number, my 75, from my 100. So my range is 25. My inclusive range, everybody in, I'm going to add one more. It gives me a 26. Okay. The standard deviation we talked about, remember we talked about that symbol right there. First standard deviation is 68. The second one is 95. The third one is 99.7. Will not change. My variance is simply my standard deviation squared. Okay, you might get a question on that formula, but they will not ask you to figure it out. They won't. They didn't ask you to bring a calculator. You don't have to bring your I-84, any of those things. It's not that. The question is definitions. Do you know what it means? So the variation, the variance is just the standard deviation squared. Okay, talked about this already. My bell curve, normal bell curve. Parametric is the term. Parametric is when all of those numbers on my distribution, I believe, are going to fit in that semicircle. That's what parametric means. Okay. So then I talked about my stanine. That's the 1 through 9. Okay, again, we're going back to that bell curve, putting those numbers on there just so I can compare them to each other. I mentioned standardized scores. So I had someone today, I don't remember who it was in my group, and I'm old. So back in the day when we took pencil and paper tests, you would go for your, ASVAB or your whatever you went to test, and they would tell you to pick up your number 2 pencil. So take the pencil and gently rip open the tab that opens the book. Put down your number 2 pencil. Open your book. All of those were standardized. Every kid in the country should have been getting the same directions because those are my standardized directions, standardized rules. So it would all be the same. So standardized scores, like I mentioned before, my Z and my T scores, they come in a raw form, but then I have to standardize them. I have to make them common so I can compare them to each other. Okay, and I said my Z score. Standard deviation is that 1, so the z-score is the same as my normal standard deviation. My t-score, the mean, the central tendency is 50. It goes up by 10, down by 10.
Dr. Pam.
Yes.
I posted a question, and matter of fact, you just covered the z-score. Could you possibly show that on the bell curve? It said the question was, what is a typical range for the standard deviation when the calculating the z-score? Could you show me that bell curve and that answer to that?
So tell me again, the question is, what is the typical range for a t-score?
What's the typical range for the standard deviation when calculating a z-score? I posted a question. Can you see me in the chat? I posted in the chat.
Hold on. I see the chat, but I got you. Okay. Okay. So what is a typical range? So, okay, let me show you. Pull that up. Go back to my. Okay, so I'm back to looking at my standard, my distribution with all my scales. That's what this is called. So your question was looking at a typical range of a z-score. Okay, so my z-score starts at 0. What I know is the typical range of a z-score. I'm going to, I think I mentioned it before, we go back to our 68, 95, 99 rule. Okay. So what is the third standard deviation of my standard bell curve? My third one is going to be in that. So look, it's 99 because, thank you, Melinda, because I'm going both ways. I'm looking at between a positive 3 and a negative 3. So my standard deviation at the third percentile, the third standard deviation, is going to be 99. So then what I know, that same normal range for my z-score is the same normal range. So then it matches up. So it's going to be from a negative 3 to a positive 3. That is my typical range for a z-score. Negative 3 to positive 3. Because it lines up with my normal bell curve. The 99th percentile is my third standard deviation. Yes, makes sense?
Okay. Okay, you're going all the way across. Okay.
Okay, so let's just look at that. So what we know is that 68th percentile is 34 and 34. Okay, there may be a question that asks you about the positive and the negative, but in general, I know that my central tendency, my 0, my mean, okay, the biggest population hovers around that mean. So 34% negative and 34% positive. A question you might see on the test talks about the central tendency, okay, or regression toward the mean. If I have a student that scores really high or really low on a pre-test, I know that on the post-test, they are going to score higher, they're going to score closer to the mean. So while they might have scored really high, so let's say they were like in the third percentile the first time, or the very low, the negative third percentile the first time, given the retest, they're going to go back toward the tendency, the mean. So they'll be back toward the 68%. Okay, and then again, you don't really need to know why. Just know that's just one of the facts when it comes to understanding the distribution. Okay, so what you just asked me is that negative 3 to positive 3, that is a standard deviation of a z-score. It's going to match up with my first bell curve line. Did that help?
Yes, thank you.
Okay. It's again, and I apologize for all of those who, including me, who have these awful teachers, and talking about research makes my anxiety rise. But what you need for the test really is not near as bad as you think. Okay, so my correlation coefficient. When we talk about our research, we know that we have qualitative and quantitative. Quantitative are numbers. 4 out of 5 doctors recommend. 30% of the people who surveyed felt this way. Those are cause and effect. Qualitative is quality. Qualitative is after you hang up from AT&T, they will ask you to please fill out this three question survey. Sprint, your dentist. They're trying to rate the quality of your experience. They're trying to correlate their business with the quality of your experience. So a correlation is a qualitative measure, and what I'm looking for is a relationship between two items. So for example, I do know that the ACT and the SAT have a very high correlation. Those are the tests it takes to get into, the good colleges. Okay. Now they're not standardized because an ACT is like a 32 and an SAT is like a 1500. They're not standardized. However, I do know they have a correlation. If a kid does well on the ACT, are the odds pretty good he's going to do well on the SAT? Yeah. Okay. I know that. That's a correlation. Up here, down, up here, up here. If he does bad on the SAT, he's probably going to do bad on the ACT. Again, those are just my correlations. So think of the number line as usual. So when I'm looking for a perfect correlation, it needs to be from a -1 to a +1. That is a perfect correlation. Okay. So then the lowest correlation I'll accept is 0.70. Anything below that I will not accept, whether it's a negative or a positive, it doesn't matter. I just won't accept it. There cannot be a correlation higher than 0. 0 means there's no correlation whatsoever. Okay, so that's my correlation coefficient. Fancy word for coefficients, the number, correlations, the relationship. Give me a number that tells us how close our relationship is. Okay, that is the same thing as the Pearson R. So we get R equals, it's the same thing. That's the correlation coefficient. I'm looking for the number that tells me how closely these two things are related. Okay. When it comes to validity and reliability, we know validity is the most important. Validity is valid. Does it do what it says it's going to do? You know, I love to cook. I love kitchen gadgets. I'm not going to lie, I do. So when I buy a kitchen gadget, I want to know, does it do what it's supposed to do? If it's a can opener that's supposed to take the lid off without cutting my hand, does it do that? That is validity. So reliability is then, does it work the same way every time? But I really don't care about reliability unless it's valid first. If it cuts my hand the first time, am I going to try it? No. So validity is the most important. Is it valid? Okay. Thank you. Validity is the most important. Thank you, Melinda. I appreciate that. We got to in the chat box. She said validity is the most important. Okay. It has to be right. Okay. So then when it comes to reliability, reliability is, can I prove it over and over again? One of those is test, retest reliability. I mentioned that earlier. We talked about whether or not we would get the same answer. So if I take a test, that my pre-test, and I wait 2.5 weeks, that's the minimum they suggest is 2.5 weeks to take the post-test, then I know those scores are reliable. Okay. What I know then is, in general with reliability, the NCE is considered an extremely reliable test. And yes, you can only take it every 90 days because the format of the test changes. However, if you study the exact same way the first time you take it, you're going to get close to the same score the second time you take it. Okay, so and I have people who take it over and over and over again, and my question will be always is, what did you do differently? Because if I don't do anything differently, I'm going to still get the same score. Okay. When it comes to internal consistency, that's the inside of the test. How consistent are those questions? Do I know they're asking what they're supposed to be asking? That's internal consistency. Okay, validity, like I said. Okay. And then types of validity. Face validity is, can you look at the name of that book and tell you what you're supposed to be taking? Okay. If you go to take the test and you open up the computer and it says, welcome to the driver's license chauffeur's certificate, that's not right. So that's not valid. Face validity is, I can look at that test and I can tell you what it's supposed to measure. Content validity is the content. Does it measure the domains that we're supposed to measure from? Convergent and discriminant validation, you will only see those with the words construct. Okay, so just know that is, you're only going to see those with construct. So construct research, construct theory are the things that are intangible, things I can't touch, things I can't really describe. So if I'm measuring happiness, I'm measuring sadness, I'm measuring your gender role, not your gender, but your gender role, I would use a constructive theory. So the words I'm going to use with that would always be convergent or discriminant. Okay, if you remember Roberts Frost, the road less traveled, and I took the one less traveled. Okay, so they converged, and he took the one less traveled. So those terms will always go to construct validity. And what I hope to teach you is that you'll know what terms to look for. Will you ever know every research term? No, but you will know enough to be able to eliminate what it's not. Okay. Tests can be reliable but not valid. We just talked about that. Power-based and speed-based. What's the difference? Exactly. My speed-based, you know how old I am, is back in the day I had to take typing class. In typing class, you had to type so many words per minute. It was speed. How fast could you get them in and get them accurate? Power test is considered the NCE. The NCE is power test. According to the writers, that you have more than enough time to take the test. So they've given you extra time to power through this very difficult test. Okay, so the NCE is considered a power test. You might see this term often. It's ipsatively. Anyone can share with me what that means? Ipsatively? Oh yeah, love a talkative group. Ipsatively is I'm only measuring against myself. Okay, I don't care what the people in front of me did, the people from behind me did. All I care is about, did I do better than I did it last time? So that's what ipsatively means. I'm interpreting, comparing the result on the test within the individual. So all I care is, did I pass the test? I don't care if you passed the test. I don't care if you made a 60 and I made a 40. Did I pass the test? That's what I'm looking for. Okay, a couple more things on here we'll go over shortly. In this test, in this section also talks about our different types of tests. Okay, IQ tests, what am I looking for? Thank you. My intelligence. Yes, yes. Okay. My IQ test is my intelligence quotient. There's also an EQ test that looks at your emotional quotient. So I think if you don't know, you probably haven't diagnosed them, but you know some people who make decisions based on emotions. And those decisions are usually poor decisions based surely on emotion. So if we can raise our EQ as well, then we can make better decisions. Okay, and what you said was intelligence. So my intelligence people are Wexler, right? He did the WACE, the WISC, and the what?
Whipsy.
The what was that? Say it again.
Whipsy.
Yes, you get the bow, the Whipsy. Those are kids from 3 to 5 who still pee-pee on themselves. That's the Whipsy. The WISC is the C for children, 6 to 16. The WACE is for adults. Okay, so yes, those are my standardized IQ tests. That WIPSI you're going to give most often if a parent thinks their child should be in school early. Okay, so we're trying to kind of look at where they are, cognitively, if they can, hang with the bigger kids. So that's when I use the WIPSI. Okay. So then, one of the things I do know when it comes to intelligence is we really used to think it was fluid. We used to think it was concrete, that I would never lose stuff that I owned, that I knew already. Okay. What I know now is that is not true. Okay. So there are fluid and crystallized intelligence. Okay. So my crystallized intelligence, unfortunately, goes down as I get older. Okay. I don't like this, but it's true. It says. Okay. Okay. So what it says is that, let me give you a different one. Okay. So then, we've always known fluid to be fixed. I'm sorry, intelligence to be fixed. You knew what you knew. You knew 2 plus 2 was equal to 4, and 6 plus 6 was equal to 12, and those things would never change. However, what we know now is we have crystallized and fluid intelligence. My crystallized is my hard stuff, the things that will not change unless I have dementia or a major, brain bleed or something. 2 plus 2 will always equal 4, and I'll know that. I'll always know that, Christopher Columbus, sailed the ocean blue and landed in America in 1492. Those are my crystallized intelligence, things that are just ingrained in me that I know. You'll see that doesn't go down. Okay, the facts that we learn, that doesn't go down. However, the fluid intelligence, which is my ability to learn new things, that one does go down. Okay, so what I know then is like, oh my gosh, that's the problem why I had struggled with trying to do things before I could do so easy. Before I would say, hey, wait a minute, I'd tell the cable company, just leave the stuff. Okay, I got this. I can put this together. Just leave it here. Lord knows now I'm like, you better come and assemble that. And it's not that my IQ has gone down. It's harder for me to process. It is really that simple. It's harder for me to process. Okay. So then that's what that is. That is my fluid intelligence. Okay. So then let's look. Okay. So crystallize, fluid. Okay. So when I'm looking at those tests, those types of tests, an achievement test, that's what I've achieved. Is the NCE an achievement test?
Yes.
It is. It sure is. You got it. Okay. So then, and then my standardized tests are the standardized tests right there. Okay. My aptitude test. Give me an example of one of those. Aptitude.
Service.
Give me more than that. Service. What do you mean?
The test we took in high school to get in the Army.
Oh, that same test I took to get out of class? Yes. We know I wasn't getting in the Army, okay? It's the ASVAB. Exactly. It looks at my potential, okay, as well as then my ability to learn. Okay, so yes, that's the same test. Yes. Okay. Am I the only one that just took it to come out of class?
I took it and passed it. I didn't want to.
Oh, you're in the mental health profession. How did you do well on the ASVAB? We don't think that way. You're just overall smart, I guess. Okay, so no, I struggled with math. Okay, struggled. Personality test. Okay, so many times we see my MBTI. That's my Myers-Briggs, right? My Myers-Briggs gives me how many choices?
16.
Yes, exactly. You can always find a sample one out there if you've never done it. I think they're pretty cool just to understand what it looks like. But you have 16 personality choices. It is based on whose theory? Come on, whose theory? Archetypes. Yes, Carl Jung. Thank you. Yes, so with my personality types, there are 16, and really you can usually find a free one out there if you're not sure where you are. So you're either an E or an I, an S or an N, a T or an F, or a J or a P. You get four letters out of those 16 choices that describes your personality. And as I said earlier, it really is based on my archetypes. Okay. And we know that Carl Jung had tons of archetypes. He really did. But there's only 4 that it's based on. Okay, so what I believe, what he believed is in all of us, there was the opposite sex. So if I'm an anima, I'm a female, then there's a mus inside of me. Okay, if I'm the shadow, you see my devil horns? Okay, so that is the shadow. So things I don't let anyone see. My persona, that's the face I put on. See that? Okay. And myself, the things that I hide from that you don't know and I don't know. All of those things are the major archetypes that Carl Jung believed that actually then came up with our MBTI. Okay. There's another one we consider a personality test. It's the MMPI. Does that one tell me how nice and sweet I am? It does not. Okay, the MMPI is this was a 547. That's the MMPI2. MMPI 1 had 556 questions. The mini version had 347, I believe. Okay, and what they're looking for is your level of crazy. Okay, this is the oldest test we have, and I've seen that on the test before, which test is the oldest. So it's the oldest test we have. So really what it looked for was looking at some flaws in your personality. So it's supposed to be written that you cannot, you can't lie. Okay, so they're yes or no, which is called forced choice. They're yes or no forced choice questions. Okay, I like mechanics magazines. I have a good appetite. I wake up fresh and rested. I think I'd like to work as a librarian. I'm easily awakened by noise. But the goal is that they repeat themselves. So if you lied on one, if you weren't as honest on one, then it would pick it up at a later point. Okay, so my MMPI is not looking at how nice you are. Okay, it is looking at your deviancy. So there are, how many scales are on there? Anybody? Such a talkative group. You guys are just amazing tonight. So based on my scores, then, and we still use this now, many people will use it for the police department still uses it. Many police departments, many times military, if you're trying to get into a high-ranking position, we'll see those. Okay, so there are 15 scales. You were close. There are 15 scales. Okay, and of my 15 scales, what I'm looking for is 1, anxiety, 2, obsessiveness, depression, health concerns, alienation, bizarre mentation, strange thoughts, anger, cynicism, conduct problems, low self-esteem, social discomfort, family problems, all of those things. Okay, that's what I'm looking for in that MMPI. Okay, so what I know then is that if I score high in those areas, then those are personality traits that we should be concerned with. Okay, so then for example, if you're high on the lowest esteem scale, or if you're low on social discomfort, you know, those are people I just might not want to give a gun to, or I might not want to give that much power to. Okay, so that's what that means with my my MMPI. So it is called a personality test, but they're really not looking about how nice and how sweet you are. Okay. So for example, let's say that you're joining the military and you're going to be in a covert operations, and you're going to be on I don't know enough about the military to know, but you're going to be with a group of men for a very long time. If you score high on the femininity cell, would you be the best choice to kind of be undercover with a group of men? You want to answer that one for me, Chris? I think he went away. No, you wouldn't want to be there. Okay, hypomania, your excitability, all of those things, again, that is based on my scales. Okay. Okay. Let's get down to some questions so you can kind of see what these things look like in the question. So there are, my understanding is there probably are about 16 questions on research and research and assessment combined. Okay, so there's some things, some terminology, some things that you just need to know. And again, they're not, to me, they're the easier ones because it really is just a matter of answering the questions, not a matter of trying to figure out like what it means. They're always facts. Okay, simple one. 50, let's look at 57. What does validity in testing refer to? And type in your chat box, guys. What does it mean? Validity. What does validity in testing refer to? Exactly. My accuracy. Does it do what it's supposed to do? Okay. If you're old with me, you've heard it before. But if you're new with me, the dollar store, and I'm not talking about the dollar store ever. I love my little Dollar Tree, but they sell pregnancy tests. Personally, I'm just not really sure how valid they are. I don't know the expiration date, how long they've been sitting there. I'm a little concerned. And if they work fine for you, I'm concerned. So they may not be valid, but they may be reliable. So reliable is if I buy 20 of them and 20 of them all tell me that I'm pregnant. Does that really mean I'm pregnant? Just because they were reliable, if my instrument is not valid, then they're still not right. Okay, so I bought 20 of them and I'm planning my baby shower and all this stuff, and I'm not pregnant because it wasn't valid. So validity is the most important. Okay, 58 asks me, what does reliability in testing refer to? So reliability is, will I get the same answer over and over again? Okay, that's the perfect word. I'm looking for consistent. Okay, same over and over again. Okay, so then let's look at number 59. We talked about this one a little bit. The only test the counselor is using with her client has a reliability of 0.60. So she should what? We talked about the correlation coefficient, and I gave you a number that is an acceptable amount of correlation, reliability. Is 0.60 good enough? Okay, so it is C. It is 0.70. Okay, so the reliability is too low, but I cannot consider the test acceptable. Okay, it has to be at least a 0.70. That's like a C average. All I'm looking for is, do these things measure at the minimum level, 0.70, whether it's negative or positive. Okay, so the answer to that one is C. I have to disregard them because they're too low. My correlation coefficient, remember, relationship between two items needs to be at least a 0.70 or higher. Okay. Sir Francis Galton, I don't know if you'll ever see this one on the test, but I just think it's a nice piece of trivia. He was the cousin of Charles Darwin. And if you remember Charles Darwin, he believed in survival of the fittest. So this is the time where Sir Francis, and he, I always see Sir before his name, but they really believed that's when the royalty was inbred, because we believe that our genetics stayed together. So he truly believed that it was inherited. Very good. It was inherited intellectual, that we got it from our people. Now, one of our current day career people does have a piece that he believes is inherited. That's Krumboltz, and we'll talk about him in a different session. But Krumboltz also believes there's a part that's genetic. Okay. So the first intelligence test was developed by Alfred Binet. So this is this is the, I don't know if you know, again, the story from your class. So Alfred Binet was in Paris, France, and he was hired by the French government. They had lots of children they were putting in kind of asylums, and they're putting them there because they really didn't know their cognitive functioning, what their IQ was. And if you know now, whether it's the WISC, WACE, or Stanford Binet, what I'm looking for is 100. Anything below a 70, then I'm looking at some mildly mentally retardation, right? But they didn't have a test to look at that. So Alfred Binet, that's what he did. He came up with this test. He tested on his children in France to look at how the test fared. Okay, so then us great old Americans decided that we would go borrow his test. So then Terman, his name, he worked at Stanford University. So he went over to France and he borrowed, sampled, stole, whatever word you want to use, the test. So now it is called the Stanford Binet, okay, because of, it was developed by Binet and then brought to the United States by Stanford. But it was really developed by Alfred Binet and Theophilus Simon. There's actually people who came up with the first intelligence test. Okay, but it is called the Stanford Binet because when it came to America by Terman, we changed the name. Okay, Wexler is my other guy, and he's got the WACE, the WAIS, remember, that's the intelligence test for adults, WISC, intelligence test for children, and WIPSI, that's the one for children younger than 5, and it's the WPPSI because they still pee-pee on themselves. That works well for me. Okay. The Rorschach and the thematic appreciation test, those are both types of assessments. Okay. What's my TAT, guys? Exactly. So my TAT is the thematic appreciation test. So if you remember Freud, and on the test, the key to look for Freud, whether it's an assessment or anything, is he believed everything was unconscious. Okay. So what he did was, his job was to teach you to bring things from the unconscious to the conscious, right? Just bring it up. So then he would have you look at these cards, or black and white faces, thematic appreciation, okay, a theme, thematic, okay, and then ask you to tell him a story or the scene behind it. So when you did that, you were bringing that up, and then he would then tell you what that really meant. He mostly worked with women. Anna O was his first case study, right? So he learned that, if you talk to women, that perhaps that would help them figure it out. So you would say, this is what I see, this is what I think, and he would tell you, oh, you poor silly woman, this is what it really means. So it was subjective because it was his opinion, as well as then projective because you're projecting your stuff out. Okay, so that is my Rorschach, which is my ink blot test, as well as my thematic appreciation test. And those both belong to Freud, and they're both unconscious. Okay, I mentioned to you before that the oldest test we have is the MMPI, so 64 is B. That's the oldest test that we have researched. Okay, So we looked at the word psychometric. All that means is testing. Someone who is a psychometric person, psychometrist, all they really look at is testing. So that would be C. They look at psychological measurements. Okay. My Myers-Briggs, just talked about that. That is the one that the archetypes are based on Carl Jung. My Myers-Briggs is a personality test. 16 choices, you end up with 4 letters. Okay. 67. So this one always gets some conflict, some questions. If this is free association. So I say something and you say something back to me. I say cow, you say right. I say house, you say exactly. Okay, so that's free association. We really most often give Freud credit for it, but it does not belong to Freud. It actually belongs to Carl Jung. Okay, so free association, again, that's from my unconscious. I'm letting those things that are hidden down there, you know, my id and ego and superego that are hidden, that I'm not letting out. So that belongs to, for the test, it belongs to Carl Jung. Okay. So we look at, what's the number that is? Let me scoot it over. A client is having difficulty deciding what career she'd like to pursue. The counselor gives her a test that would help her make an informed choice. What type of test would she give her? I see, an aptitude test. An aptitude test? Okay. So then personality test is her personality. I wouldn't do that, right? An aptitude test is looking at the ASVAB, whether how she's good at that. Psychoanalytic is Freud, okay? An achievement test is my NCE. So I'm probably giving her, she has to make a career choice. She has to make a career choice. Okay, so I'm going to give her an aptitude test. Let's look at what she's good at. Okay. There's some group questions. I'm going to come those that are a different day. Okay. Pick up a little bit of that research. Okay. So let's look at number 107. A counselor wants to measure happiness and decides he will keep track of how many times his subjects laugh in the course of a day. He writes down every detail of his study so it can be replicated, specifying the measurement of smiles as he determines happiness level. What have you provided? Okay. That one is B. It's an operational definition. So he's doing the research, but he's measuring smiles. Okay, and the only way that he can measure smiles really is based on the only way he can measure smiles is by telling you measure happiness, and he's measuring it by smiles. Do we all measure by smiles? So happiness for people, some people means a lot different things, right? Okay, but he did it by smiles. Okay. Okay. So then, okay, this is a sampling question. In a research study, every element of the population has an equal chance of being sampled. What type of sampling is this? Okay. So then random sampling, systematic, stratified, or equivalent. Okay. So yes, everyone has the same chance is random. I'm standing outside the Whole Foods and, you know, I take everybody who comes up, random, 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 right? Systematic, what's that, guys? Systematic is if I have a system, okay? So my system is every third person, every sixth person, every eighth person. That is my systematic, okay? Stratified, so I'm going to be brave and try stratified for me. So stratified is, okay, so systematic is every sixth, seventh, eighth person, whatever number I choose. That's systematic. Stratified means that I need a certain category. And don't ask me why, but I always think of like the stratosphere. Don't know why I do, but I do. Stratosphere. Okay. So then my stratified is really looking at this certain level. So I need only Black people. I need only women between the ages of 16 and 27. I need only men who are 6 feet over, etc. I'm looking for a very specific type of group. So they have to fit in my category. Okay. There's something else called proportional stratified. So proportional stratified is when I'm trying to measure what my bigger population looks like. So for example, I've got this, I work at a college and I'm trying to do a random survey on the success rate of students in our college. So let's say that our college is 40% African American, it's 20% white, 20% Asian, and 20% Hispanic. Okay, so in order to get a proportional stratified, I have to make sure that it matches. So, but it's still going to be a random. So if I need 4 Black people, I'm still going to try to get 20 Black people in and then randomly pick 4 out of that category, right? If I need 2 Hispanic people, I'm still going to get 50 Hispanic people in, pick 2 out of that category. Okay, so the problem with that is if we do just simply random, it won't match the population that I'm looking for many times. So we know that in the United States is, depending on what city you live in, but it's mostly about 60% white. So if I'm looking at a survey that matches my population and my school, the college doesn't look like that, then that's not a fair sample. Okay, so what I'm looking for is it's called proportional stratified. Okay. 109. A study measuring the IQ level of a group of men of different ages performed on a single day is most likely an example of what? Single day, group of men, different ages. What is that? Okay. That's my cross-sectional. Okay. A group of men, so it's not stratified because it's just that same time. Okay, so the same time is a key there that makes it a cross-sectional. So what I'm looking for is just, if I'm doing some research on COVID and I want to know how COVID has affected you, okay, but I'm only looking for men. So again, all I'm going to do is, maybe go to, I don't know, 5 places men hang out. I'm sorry, with COVID, I don't know. But I'm going to take a cross-section of this group and this group and this group all at the same time. Okay, it's a snapshot. So, on August 15th of 2020, this is what it looked like. Okay, so then that's a cross-sectional. What's my longitudinal study?
Over time.
Yes, got it. Give me an example of a longitudinal study.
From when a group of people was probably in kindergarten until they got in college?
You got it. You got it. One of the most common ways I know that smoking is bad for you is because of longitudinal studies. Okay, I don't know if you're old enough to remember, but the Marlboro Man used to be very cool. There were in magazines, on TV, there were tons of commercials with smoking, and it was very cool. Back in the day, I'll show you my age, high schools had a smoking pit. So if you were old enough, the teachers and the kids went out and smoked. Okay, now we know that smoking is bad for you. We know all the consequences that can come from smoking, and that only is based on longitudinal studies. Okay, COVID. You know what? Will we know the true impact anytime soon? So there's some researcher now who's doing some studies of babies who were just born and babies who were born before COVID, and he's going to follow them for the next 18 or 20 years to figure out like how it changed things. So my longitudinal studies are long-term. Of course, the problem with that, of course, is getting people to stay on with your research that long, but that's very common. I mean, that's what it looks like, okay? Okay. 110, this is just a term that you should know. It's in our research section. A counselor decides to study how elementary school students behave in classroom when adults are present, as opposed to when there are no adults present. A few classes volunteer for the study, and the counselor explains to them how the study may help them avoid future behavioral problems in the classroom. Which of the following is the counselor likely to see? Okay, so then, what is that called? Bingo, that is my Hawthorne effect. Okay, it can be called the observer effect, but for the test, it's most often just called the Hawthorne effect. So when the mouse is away, when the cat's away, the mice will play. So many of you, when COVID first hit, were working from home. And a lot of my clients I was working with, and they were talking about how much harder it was working from home because your supervisor was calling you every 5 minutes. Because the theory is that if I can't see you, obviously you're not working, right? So that's the Hawthorne effect. Okay. We went over these a little bit. A 17-year-old client has been referred for intellectual testing. What test are you going to use? Intellectual testing. Yes, I am. I'm going to use the WACE. Got it. Because WACE has to be 16 or over. Exactly. So that's a question that you might see that might try to trip you up. Perfectly. That's the WACE. Okay. So 113, he's an 8-year-old, so he would use my whisk. Okay, he would use my whisk. Okay. Down. Okay. Oh, I like this one. 117. In an experiment, what is the independent variable? What is the independent variable? Okay, so if you haven't had me before, I always love to explain my variables. Okay, so if you've read Rosenthal, he always talks about your body is a DV, dependent variable, and the IV is the independent variable. So you're kind of waiting for the IV to work to fix your DV, right? So that's your dependent variable. It's laying here waiting for the independent variable to fix you. So then my dependent variable is my glass of water here, right? You can't see my cup, but got my little plaid, a cup of water. So can it go down to the kitchen and get anything by itself? It can't change itself at all. Only the independent variable can affect my DV. So my independent variable, let's say that I want to go down, and let's go ahead, so I've got my glass of water, and I want to try Country Time, the lemonade squeeze, and I want to try Crystal Light in my second experiment, and I want to see the difference. So Crystal Light and my the other one are both kind of, I'm doing two separate experiments, right? So the independent variables will manipulate my dependent variable. My dependent variable is the one that will have the change. Okay, so the element that changes or manipulated. Okay, so how about A, the experimental factor? So the independent variable is not, it's the manipulator. Okay, the one that's changed is my dependent variable. The experimental factor is what I squeeze into my bottle. Okay, so dependent variable sitting here, it can't do anything by itself. Okay, so while I said that, I said there were two different things, two different test items I was putting in my dependent variable, which is my water. That's a t-test, guys. Not to be confused with a t-score that was on my line over there, but if I'm doing a parametric test, I'm assuming my numbers will come in a normal distribution, then I use a t-test. T-test means two independent variables with my dependent variable. That's going to be my t-test. Okay? So the one that experiments, not the one that's being changed is my dependent. The one that does the changing is my independent. Okay. We talked about this a little bit earlier. A correlation coefficient. That's that. One, the positive one, the negative one. That's a correlation. So tell me 120. A correlation coefficient shows what? How about D? How strong the relationship is, because the closer the number is, the stronger. The direction. So I can have a positive or a negative. It goes up or it goes down. Okay, and also then the degree of relationship. So, what tells me how close these two things are related? So the best example of that, of course, would be my ACT and my SAT, right? So my ACT and SAT, I both need to get into college. So my ACT, if I do really well on one, they have a very close correlation because most colleges will take either the ACT or the SAT. So strong correlation, probably like a 0.95, really close. If I do well on my ACT, am I going to do well on my SAT? I should, because there is a strong correlation. If I do bad on one, should I do bad on the other? Exactly, I sure should. Okay, so that is my correlation coefficient. Okay, so that's what that looks like. Okay, last question, guys, 121. If there's 95% that an experiment's results are not due to chance, one might say the experiment is. Let me go back 1 second. My correlation coefficient is also called the Pearson's R. So you might see R equals. That's the same thing. That's my Pearson R. Okay, so 121 then. I'm sorry, go to that one. The number 121 is known as the P. So if the correlation coefficient is the R, the P is your probability. Okay, and the probability is saying that there's a 0.05% that these two things happened not by chance, that there is a correlation between those two. Okay. Okay. Any brave ones? So correlation coefficient is not, that's an R, that's not a P. P is probability. Okay, so then what I know then, if there's a 95% that the experiments are not due to chance, I'm going to say it's statistically significant. So it's D. It is D, statistically significant. The probability of this happening, okay? So if my probability is only 5%, okay, I can tell you that it's significantly, it didn't happen just by chance. It's significant that I did an intervention and that this changed what it looked like. Okay? Okay, guys, I have to wrap you up. It has been a pleasure as always. I'm going to stop recording. Okay, stop recording. There we go.